Hello everyone. In this video, we are going to discuss the last practice exercise from chapter 2, that is coordinate system and transformation. So here in this case, we are given with the two vectors, that is vector A and vector B. And here in this case, we have to find out very firstly what is the dot product in between vector A and vector B. Then we have to find out what is the cross product in between these two vectors. And then we are going to find out what is the vector component of given vector A along AZ direction at given points. So these are the three given points that we have. Okay, so we will start with what is given to us, and then very firstly we will move for its A, B, and C part. Okay, so very firstly we are going to write what is given to us. Okay, so we are given with the two vectors, that is vector A, which is if you are going to observe these two vectors, so it is given in terms of that r, theta, and phi. So that basically is what? That is the spherical coordinate system. So we have the given vector A, which is basically expressed in terms of spherical coordinate system, having the components along that AR and A, theta, and phi direction, which is 3, 2, and -6. And the next is we are given with vector B, which is 4AR plus 3A5. So for your convenience, if you are going to observe that one, we can find out that there is no theta component over there. So for your convenience, I have written it, that is whatever that a theta component, it is with the zero magnitude. Okay, so very firstly we are going to find out the part A, or you can say the, yes, part A of your given numerical, which is what? The dot product in between that given vector A and vector B. So you might have gone through my previous videos where we have taken the dot product in between the two vectors. So that would be what now? So simply we are going to rewrite that vector A, which is basically what? 3AR plus 2A theta minus 6A phi, and second is your vector B. So that vector B is what? 4AR plus, since we have the 0 theta component over here, so for your convenience I am going to rewrite it as 0 a times of a theta plus 3a phi. So the from basic theory of the dot product in between the two vectors, we can say that the dot product in between the two same vectors is what? 1. So here in this case, and for the rest of the case, we will have that product to be what? 0. So dot product in between the two same vectors is 1, and the dot product in between the other two vectors or dissimilar vectors are what? That is equals to 0. So using that theory, we can find out the 3 multiplied by this 4 is what? That will be 12. Okay, and if you are going to multiply this AR with respect to A theta, that's so that will be 0. If you are going to have the dot product in between this AR and A phi, so that will be again 0. So since that terms are 0, I am not going to rewrite it for you. Now next is what we have? Theta component. So what is magnitude over there? So we have that to be the 2, and here in this case theta magnitude is what? Which is 0. So this 2 multiplied by 0, so that will be again what? 0. The next is what we have? This -6, which is along the phi direction, and here is 3. So -6 multiplied by 3, so that will be what? That will be minus of 18. Okay, so ultimately what will be our answer? So we can say that the dot product in between that vector A and vector B, which will be nothing but what? Minus of 12 minus, okay, so that will be -6. Okay, so we have this as our final answer. So dot product in between the given two vectors, that is vector A and vector B, is what? Minus of 6. So this is our very first answer. This is quite simple one. So there is nothing challenging within this one. Then next is we are going to move on to the part B, which is where we are going to find out the cross product in between that given two vectors. Okay, sorry, something went gone wrong. Okay, so now again we are going to see the part B of the same numerical, that is 2.4, where we have to find out what is the cross product in between that vector A and vector B. So if you are going to if you have referred my previous lectures, you can have the uh, analogy how to calculate the cross product in between the given two vectors. So I am going to rewrite it for you again over here. So we have the vector A and vector B with its cross product, and if you are going to observe that given vector A and vector B, so they are expressed in terms of spherical coordinate system. So we are going to write that to be like this one. So we have AR, A theta and A phi component for that given two vectors. And what are the magnitudes along R direction? So we have for vector A this to be the 3. For theta we have this to be 2, and for phi direction we have this to be minus of 6, and for vector B we have 4 as component along R direction, 0 component along theta direction, and 3 component along phi direction. So we just have to take the cross product in between these quantities. So very firstly we are going to write this AR as it is. Now take the cross product. So what will be the cross product for that very first bracket? So this will be this 2 into 3, so that will be 6. Then this minus 6 into 0, so that will be 0. Then plus A theta as it is over here. Then next is cross product in between this minus 6 and 4. So that will be what now? That will be minus of 24. Then 3 into 3, so that will be minus of 9. Then we have that A phi component as is over here, and then next the cross product in between this 3 into 0, so that will be 0, and this 4 into 2, so that will be minus of 8. Okay, and if you are going to simplify that one, so you will find the cross product in between that vector A and vector B is equals to 6 times AR minus 33 A theta minus 8 A phi. Okay, so this is not our final answer, but why? Because they are going to ask you what is the magnitude of that vector A and vector B with its cross product. Okay, so we just have found out what is the cross product in between vector A and vector B, and its magnitude will be what now? Square root of square of components along that r theta and phi direction. So we have the very first component to be 6 square, then minus of 33 square, then minus of 8 square. And if you are going to simplify that one, so you will find that the cross product of that vector A and vector B, it have the magnitude of around 34.48. Okay, so this is our answer for part B of the same numerical. Now next is we are going to see the part C of the numerical, where we have to find out what? Here in this case, part C, we have to find out what is the vector component of your vector A along the Z direction, is it? Now there comes the tricky part. Okay, so what is that one that we are going to see over here? Okay, so we are given with vector A, which is basically expressed in terms of its spherical coordinate system that we have earlier discussed. So I have written it for you and assign some equation number to this one if we have to make use of this one. So I'm going to say this to be the equation 1. Now here in this part C of the numerical, they have asked what what will be the vector component of vector A, which basically is in it, which basically is in its spherical form. And here, if you are going to observe that one, we have to find out its direction along AZ. Okay, so AZ is what? It is given in terms of its Cartesian coordinate system. So we just have to convert our given vector A, which is basically a spherical coordinate system, into its Cartesian form, and then we are going to find out what is the vector component of vector A along AZ direction at given point. Okay, so again that points are given in terms of its spherical system, because what we have this one as r, then we have pi by 3 as our theta, and this pi by 4 5 pi by 4, which basically is what? Phi. Okay, so we just have to make use of some equations that we have earlier discussed while we are going to convert that spherical system into its Cartesian system. Okay, so we are going to make use of that conversion table. If you have referred my previous lectures, we have already done this part, but here in this case again we are going to repeat that one, but we are going to make it as simple as possible. Okay, so I'm going to write that vector A in Cartesian form. Cartesian form of our given vector A. It will be what? Will be expressed in terms of x, y, and z components. So we have this to be the ax plus ay plus az. So what is that capital ax, ay, and az? So these are nothing but the components along your unit vectors, which basically is expressed in terms of this smaller ax and ay and az. So this is what? So capitals are said to be components, and that smallers are said to be what? Your unit vectors. Component along the given unit vector. Okay. Now here in this case, we are going to make use of that conversion table. So I am going to put that conversion table for your reference over here. Okay, so this is the conversion table that we are going to use. But for now, very firstly, we are going to make it simple by having we are going to just take the dot product in between your given vector A along with this AZ. Okay, so what exact is that that you will see. Okay, so very firstly in that C part, what they have asked, they have asked us to find out the vector component of vector A along the AZ direction. So rewrite that one, vector. Okay, let me pause this. Okay, so if you have referred my previous videos, we have found out what is the scalar projection and what is that vector projection. So what is the vector projection or vector component? That is nothing but what? A scalar projection having a product with its unit vector, or make it simple, we just whatever is vector component of given vector, it, it will be have a dot product with respect to the direction given. So here in this case, AZ is the direction given. So this is what we have. Given vector, it will have a dot product with respect to your this given unit vector. Okay. And then again we have to multiply it by using this given vector, given unit vector. Okay. So keep in mind whatever is vector component of your given vector. So here in this case, A is your given vector and along your given unit vector. So this is the difference. We have this to be as your vector, and this is what we have, unit vector. So that gives you the vector component. So that basically is what I am writing it for your reference purpose. No need to write in your theory, this in your theory exam. So that will be what now? Keep in mind, vector component or vector projection is what? Your given vector having the dot product with respect to given unit vector multiplied by, this is the simply multiplication along with the unit vector itself. Okay, so keep in mind. Okay, so I'm going to rub it because this is just for your reference purpose. Okay, so we have to take the dot product of our given vector A with respect to your given vector, which is AZ over here, and then again we have to multiply it by using your given unit vector. Okay, so earlier we have written that what is vector A in terms of its Cartesian system. So very firstly we are going to find out what is the this very first bracket. Okay, so we are going to simplify that one. So that vector A in terms of its Cartesian system is expressed in your equation number 2. So what is that one? So that is ax plus ay plus az, and it will have a dot product with respect to your az component only, and then you have to multiply it by using az component. See, if you have referred my previous video, so there in that case, what we have done, we have found out what is that AX and AY and AZ and all that. But for this numerical, we are concerned with the vector component of your vector A along Z direction itself. Okay, so that's why we have directly jumped onto this part. we are not going to simplify for this AX and AY component. We are concerned with this, the Z direction. And if you have enough practice, okay, so if you are not beginner, if you are quite expert within that one, so there in that case you just can directly go with this one, this part. There is no need to go with the other part. Why is that one? Because earlier we have seen in the same numerical, so dot product in between the two same vectors is 1, and for the rest we have the value to be 0. So there is no use of writing these terms. So what the ax dot az, so that will be 0, ay dot az, so that will be 0. What is left? So we are left with this az dot az, which will be 1. So because of that one, we are left with this az component only. So you can skip that part if you are quite expert within that one, and if you are not, so I will suggest to go by following these steps. Okay, so this is for your reference purpose only. Okay, fine. So I'm going to rewrite it for you. AX, what is left? AZ. Yes, AZ. It will have a dot product with respect to your given unit vector, which is AZ, and then it is to be multiplied with this AZ. Okay, so take the dot product in between that two vectors. So ax dot az, this ax and this az, so that will be 0. Dot product in between this ay and this az, so that will be again 0. And so the dot product in between this az and this az, so that will be 1. So what is left? We are left with this capital Az, which is basically is what? Component along the z direction. So this is what we have within that very first bracket, and then it's to be multiplied with this Az. Okay. Okay, so well, I hope this cleared you. Now next is we are going to write what is that Az. Sorry. Okay, so we have this as your vector component of vector A along Az, which is basically what? Az and then Az. So what exact is that Az? So that component of given vector A along z direction is nothing but what? Your given vector A having the dot product along with respect to its unit vector, that is Az. You can refer to my previous videos if you are confused for now, and if you have referred already that one, so you have that logic why we are going to write it like this one. So Az will be what now? Vector A having the dot product with respect to the unit vector along z direction, that is Az. So what is our vector A? So we have that vector A to be what? 3 AR cap plus 2A theta cap minus 6A phi cap. It have the dot product with respect to the z direction. Okay. Now we are going to make use of that transformation table. Okay, so find out the dot product in between that AR and AZ. So the dot product in between that AR, so this is what we have, AR and AZ. So like this one. Dot product in between that AR and AZ will be what now? Cos of theta, which is with the 3 magnitude. So that will be what now? 3 cos of theta. Then next is dot product in between that A theta and AZ. So dot product in between that A theta is what? And AZ. So that will be again what? Minus of sine theta. So that too will be as it is. So that will be what now? Minus of 2 sine of theta, and dot product in between that A phi and AZ. A phi over here and AZ. So that is 0. So we are left with this value only. So that is what? 3 cos theta minus of 2 sine theta. So this is what? This is our AZ. Okay. Now put the value of theta over there. So what is that theta? We have theta which is given to be pi by 3. So we have to calculate that AZ at theta equals to pi by 3. So, well, I hope you will put that values and calculate that one. Simply, you just have to replace this theta by means of this pi by 3. So that will be cos of pi by 3. And here in this case, that will be sine of pi by 3. And if you are going to simplify that one, so you will find that answer to be, okay, let me write for some beginners. If yours are beginners, you can see this one, and if you know about this one, you can skip this part. Okay, so that is what cos of pi by 3 minus of 2 sine of pi by 3. Okay, and if you are going to simplify that one, so we have this az to be minus of 0.232. Okay, so this is the az value that we have. Say this to be equation what? Say this to be some equation A or whatever, because we are going to put this minus 2 point, sorry, minus 0.232 within this one over here we are going to put that one. Okay, uh, let's say this to be equation A, and let's say this to be equation B. Equation B. Okay, now we are going to simplify that one. So we are left with what? Vector component. Here given vector A along az direction is what for now. So put the value of this az, so that is what, minus of 0.232, and this az will be as it is over here. So this is what, but still this is not the final answer. Why is that one? Because this az, it have its own value. So how we are going to say that it have its own value? For that purpose, we are going to make use of this reference table again. Okay, so again we are going to make use of this reference table where we are going to find out what is the value of that AX, AZ, and AY. Okay, so if you are going to observe this convergent table, so Cartesian vectors, or you can say, I'm going to change the ink for your reference purpose. So it is not expected that you are going to write in your theory exam. We are just concerned with that AZ component. So what is that Cartesian components? Components of spherical vectors are. This is already given in your book, that is Elements of Electromagnetics. So this convergent table, from that you can write that one. So very firstly, what we have AX. Now if you are going to see this AX over here, so what are the components that we have on r, theta, and phi direction? So simply that is your vector components. So AX, it is having sine theta cos phi AR. So this is what we have, sine theta cos phi AR. Then next is what we have, cos theta cos phi. So that is what, plus cos theta cos phi A theta, and then minus of sine phi. So that is what, minus of sine phi A phi. Okay. Then next is what we have, AY component. So again make use of this one. So AI is what? Okay. So this is what we have, sine theta Sin phi, this is AR. Okay, then plus over here cos theta sin phi. So another term will be what now? Cos theta sin phi a theta. Then final term is what? This cos phi. So that is what? Cos phi a phi. Okay, so this is your AY component, and this is the final component that we are going to make use. So we are with this AZ. So AZ is what? We have that AZ to be what? Cos of theta AR cap, then minus of sin theta a theta. Okay, so these are the Cartesian components of your given spherical vectors. There is reference of this your convergent table. Okay, now we are going to make use of this one within our numerical. So using this, we are going to write our equation, say C. You can put whatever reference for that vector. Okay, using this, C can be written as okay. So what is that C? We have C to be minus of 0.323, sorry, minus 0.232. Sorry. Okay, then next is AZ. AZ is what we have. AZ we have this to be the cos theta AR minus sin theta A theta. Okay, so we are just going to put the values of that theta over there and simplify that one. So that we have already discussed. Theta is what we have to that to be the cos of pi by 3. So that will be what now? Minus 2.32, sorry, minus 2, minus 0.232. Okay, that's what is cos of pi by 3 AR minus sin of pi by 3 A theta. So this is what we have. And again, if you are going to simplify that one, so you will find that answer to be like this one. So ultimately, I'm going to write that final answer. So that will be minus of 0.116 AR plus 0.201 A theta. So that is what? That is your vector component. Sorry. That is what we have, the vector component. Vector component of your given vector A along Z direction. Okay, so with this we have ended all of the practice exercise from your second chapter, and in the coming videos we are going to see the numericals from your chapter 3. Okay, so if you appreciate my videos, please do hit the like button. If you have anything feedback for me, please write it in the comment box, and please do subscribe my channel. Okay, thank you. Bye bye.